scientists might have discovered life outside the solar system. Welcome to planet K2-18b. This exoplanet is 124 light years away from us, and it has the most promising evidence for life we've ever found.
Hey Chaseheads, it's your boy Chase here on a mission to find the most precious thing in the universe. Aliens. Finally, I'll have someone to talk to around here other than Rico.
Correction. You have not initiated a meaningful conversation in 172 days, 3 hours, and 9 minutes. Statistical degradation of your social skills is within the expected parameters.
Okay. Ow. Rude.
K2-18b is 2.5 times bigger and 8.5 times more massive than Earth. And it orbits an M-type dwarf star, which is cooler and redder than our Sun. Scientists don't know for sure whether this world is a super Earth or a mini Neptune, so we're sending our brave team member Chase to find out. It's possible this exoplanet has internal heat under all that dense atmosphere, which could mean that it's packed with volcanoes. It could even be covered with a massive ocean. 124 light years is pretty far, and of course we don't have the technology to get there yet, but we do know something intriguing about this big alien rock. Scientists have found that K2-18b has dimethyl sulfide and dimethyl disulfide in its atmosphere. And that means it could be teeming with life. And if we can find life here, that would mean that alien life could exist on other planets too.
Yeah, but humans would likely never find any of it. I mean, exoplanets are like super far away. You'd die of old age long before you ever saw anything cool in space.
He's not wrong. The fastest human-made spacecraft we've ever created is the Parker Solar Probe. This little craft was designed to fly close to the sun, and when it did, it reached a speed of 692,000 kilometers per hour. If you could travel that fast, it would still take you 193,399 years to reach this alien destination. Give or take a month, and depending on traffic.
So the science is pretty clear that K2-18b is gonna be pretty amazing. Volcanoes, alien life, beaches, it's gonna be pretty cool.
The science is getting clearer, but we're still just making intelligent guesses of what K2-18b could be like.
Guessing, amazing.
To explore these planets from such a long distance, we use devices like the James Webb Space Telescope. Space telescopes are a lot more accurate since they don't have to look through the smudged lens of Earth's atmosphere. The James Webb Space Telescope sits about 1.5 million kilometers from Earth, and from there, it has a clear view out into the universe.
Hey, I'm right here, and the view is pretty clear, baby.
Yeah, sure. Okay, even though these alien worlds we keep discovering are far away, we still have a way of learning a little bit about them. Like, how do we know there's dimethyl sulfide in K2-18b's atmosphere? 2 words: transmission spectroscopy. Here's how it works. When a planet like K2-18b passes between Earth and its own star, it blocks some of its star's light. Then, astronomers use powerful telescopes like James Webb to observe the starlight that has passed through the thin layer around the edge of the planet. It helps that different gases in the atmosphere absorb specific wavelengths of light, because scientists can measure exactly which colors get absorbed, and from there, they can identify which gases are present in a planet's atmosphere, even though it's incredibly far away. We can even tell how much of a particular gas there is, the atmospheric density, and the temperature of the atmosphere.
Guys, I'm here about to dive into this beautiful planet, K 20, 80, whatever, and be the first astronaut ever to encounter real alien life. I'm also planning a vacation because, firstly, I deserve it, and B, treat yourself, and 4, this planet is the perfect spot. And I mean perfect, because it's like Hawaii, but with aliens. Stay tuned for more. Okay, so how do I dress for this planet? I am hoping for cargo shorts weather.
Well, you're in luck, because as far as astronomers can tell, K2-18b is pretty balmy. Its surface temperature is close to Earth's average temperature. It's warmer in some areas and cooler in others. This might just be the perfect destination that we've been searching for.
Okay, I'm signing up for warmer areas, and I'm gonna go with pants. Now, what kind of pants does somebody wear to meet aliens for the first time? Something formal. Yeah, cargo pants.
Unable to locate cargo pants.
Well, pants or not, this is gonna be sick. Aliens, finally something exciting. Oh man, I see the planet, I land on the planet. Rico, do the thing, initiate landing sequence.
I wouldn't recommend that. You see, K2-18b isn't the only planet in the neighborhood. It shares its red M-type star with a much bigger sister planet, K2-18c. That's the one you're looking at right now. K2-18c is 7.5 times the size of Earth, but bigger doesn't always mean better. At that size, it's closer to Neptune with one of those unwelcoming hydrogen and helium atmospheres. K2-18c is unlikely to host any known life forms.
Initiate those stabilizers! It'll... Yeah, I died on Neptune pretty grossly, so yeah, it's gonna be a hard pass for me on the C planet. Today, I'm taking a me day on K2-18, whatever, the B planet. Okay, so little update here. Turns out I was at the wrong planet. Whoopsies. Almost landed on a mini Neptune, and I don't want to go to Neptune anymore. Yuck. So yeah, that was a close one. Luckily, I realized that in time, and now I'm on my way to this beautiful, correct planet.
K2-18b is 2.5 times the size of Earth, which makes it a super-Earth. Super-Earths are planets at least 1.5 times larger than our blue rock. Some of these lower-density super-Earths could have atmospheres made up largely of hydrogen and helium. You might sound funny on them, but they're not good for life. But super-Earths with a higher density, exactly like K2-18b over here, could be rocky worlds with shallow oceans.
Just the paradise this guy needs. Rico, initiate landing sequence, preferably someplace poolside.
I have identified a series of volcanic islands.
Yeah, I see them, genius. Alright, finally some R&R and a suntan.
Danger. Unstable ground. Landing not recommended.
No. I did not just almost land on the wrong planet to turn back now, Rico. Initiate landing sequence!
Initiating landing sequence.
Rico, we have an autopilot for a reason. Next time, just use that. Oh my god, that was the worst landing. And I've piloted this thing before. Rico, give me a temperature reading. It feels nice.
Temperature reading 16.15 degrees Celsius.
Okay, now do a better job analyzing the atmosphere than you did landing. Okay, Rico?
Analyzing. Detecting nitrogen, methane, carbon dioxide, with traces of dimethyl sulfide.
And oxygen?
No oxygen detected. Keep the spacesuit on.
Wow, it's gonna be real hard getting a suntan with a spacesuit on, but whatever, Senior Buzzkill. I guess I'll leave it on for safety.
Even if there was oxygen, the surface pressure here is 3 times higher than on Earth. You'd need to keep your helmet on at all times. That's because the sudden increase in pressure could make your ears and sinuses implode, and your lungs would collapse violently. You'd be in excruciating pain, gasping for breath, with your vision blurring from burst blood vessels around your eyes.
No. Didn't you get the memo, Peter? I am not dying on this one. No more Mr. Die Guy.
Even with your spacesuit off, the thick clouds would prevent the sun tanning process.
Well, thanks for the tanning tip, buddy. So this has been nice. Not too cold, not too hot. Rico didn't let me suntan earlier, which is a bummer, so I will remain the pale space adventurer that you all know and love. One day I will find my Ryza, that planet for the perfect vacation. But today is not that day. Still, good news is that I am looking for aliens, and there is a good chance that I'll find some, so keep watching, friends. Ooh, this gravity's really gonna cramp my layups.
Gravity reading, 1.3 times Earth's gravity. It is not substantial enough to result in such poor performance.
I am not out of shape. Okay, those late night Moonburger orders, they mean nothing. Oh God, Rico, where's a chair? I need a chair. So, aliens. How come there's none around, I feel like I've been looking for these guys for, ever, And I've only found Charlie, and I'm still not entirely convinced that was real or my imagination. Brain does weird things when you're dying of oxygen deprivation.
Why are aliens so impossible to find? Great question.
Please don't say 2
And
words.
I have 2 words for you.
And there it is.
Fermi paradox. You see, with all the billions and billions of planets out there, you think we would have encountered aliens by now. Scientists have been looking for signs of intelligent life in the universe forever, and we haven't detected anything yet. One physicist in the 1950s had a theory.
Oh, let me guess. It's called the Fermi paradox because Fermi was the dude's name, and it's called a paradox because it doesn't make any sense?
Sure.
No, don't sure me. Okay, I am the lifeblood of this channel.
So far, trying to answer the Fermi paradox has created a lot of speculation as to why we haven't found signs of life anywhere in the universe yet. Maybe intelligent life is out there, but cosmic distances and timescales are so huge that we've just missed each other. We've only been looking seriously for alien life with radio telescopes for just over 60 years. And what's that compared to the age of the universe?
Yeah, I can relate. I lost a sock on this ship once. It's not that big a ship, and I only looked for like a minute.
Another possible answer is that the aliens just don't want us to find them. Maybe they're scared of us, or maybe they just want to sit back and observe us.
Yeah, it's like we're gorillas in a zoo and aliens are just waiting to see if we'll beat each other with sticks or something.
Some scientists have even wondered if advanced technology might be a kind of ticking time bomb that eventually blows up in a civilization's face. This idea is part of what's called the Great Filter Theory. Basically, once a species becomes powerful enough to build rockets and explore space, it might also accidentally create the tools of its own destruction. Think nuclear war, unstoppable artificial intelligence, engineered pandemics, or catastrophic environmental collapse. This could explain why we haven't run into any space-traveling aliens yet. They might have wiped themselves out in some apocalyptic event before ever leaving their home planet. So, what kind of alien life forms do you expect?
I don't know, something like cool and chill, like non-life-threatening at all kind of aliens. I don't get it. K2-65F is supposed to be this planet with all this life teeming everywhere. Where is it? I don't see any. I don't see any life around here. This seems like a load of bull spit to me.
K2-18b could host life. Doesn't mean it does. Scientists use the concept of biosignatures to determine if a planet could support life. The idea is that if chemicals associated with life on Earth are detected on another planet, well, then that means those chemicals might come from life on that planet. The big one is always oxygen.
Okay, wait. First you say that the transit spectroscopy has detected no oxygen. Then you say oxygen is life. But which is it, Peter? Why am I even here? Where's the life? And is it Laurel or Yanni? Somebody tell me!
Don't get discouraged. There could still be alien life here.
Sure.
Don't sure me. Because not all life is associated with oxygen. There are two other important chemicals here: dimethyl sulfide and dimethyl disulfide. On Earth, they're produced by marine phytoplankton and bacteria, and the concentrations of these gases on K2-18b are much higher than on Earth. K2-18b could be teeming with life. You just can't see it with your naked eye.
Marine phytoplankton, eh? So, aliens in the pool, but not aliens poolside. Not the kind of life I was particularly hoping to find, but, give them a few billion years. Don't rush them. Maybe they'll develop. Okay, here's a quick update, Chaseheads. So far, no aliens. I know, bummer. But there could be these, tiny little aliens, sea monkey type people here, If they are here, I can't see them. But I will find them, because I have a particular set of skills. Let's see what we've got here. Hello, phytoplankton! Can you hear me? Whoa, okay, hey, this is not the vibe.
Did I mention that K2-18b has active plate tectonics? Because it has such a high mass, this alien rock likely retains a lot of internal heat. That can cause earthquakes and volcanic eruptions.
Yeah, I see a volcano right in front of me. Thanks, Peter. And also, shouldn't these really be called K22F42 quakes or whatever? Ugh. Oh. Why did we land beside a volcano?
I did warn you.
Okay, kids, vacation's over. Oh, that was close. Okay, this is not looking good. I did not see any aliens, and I am now experiencing a quake. And, a volcano's erupting right behind me. That's kind of cool. Still positive I can make it to the ship, though. I'm gonna keep running. Check you Chaseheads later. Rico, take off!
Looks like Chase got away this time.
Okay, I didn't find any aliens to talk to, and, I didn't get a tan. Or any rest. But I didn't die this time, so that should count for something, right? Hope this vlog wasn't like a complete disappointment to you guys. The view, that was nice, right? So there's that. Okay, the main thing is, I survived, baby! Chase doesn't die in space! How about that, Richard? I survived! K2-18B! Rico, you know what time it is!
Would you like me to launch congratulatory sequence?
Please do, baby! Peter, any comment?
Well, I guess I was wrong.
That's another first, baby! Peter admits he's an idiot! This is the best day ever! Pure, clean, recycled air.
Warning. Contamination detected.
What? What? Contamination? Contamination? I always wipe my boots according to 54-B, whatever it says in the training manual.
Contamination.
Oh, okay, I might have skipped it this one time.
Well, that was a big mistake. Let me pause Chase for a second and tell you about the moon landing. Back in the 1960s, when humans went to the moon for the first time, protocol required them to quarantine for 21 days after their return home. Yeah, astronauts spent 3 weeks isolated in NASA's mobile quarantine facility, just to ensure that no dangerous moon microbes could sneak back home. And that was the moon, dry, airless, and relentlessly bombarded by radiation. K2-18b has so much more potential to host life. You need to take decontamination seriously.
Maybe we haven't found aliens because they're so small we can't even see them. I think I might be breathing little tiny aliens right now. Hey, did that Fermi guy ever think of this?
I think you might have solved the Fermi paradox. When scientists look for signs of life in the universe, they don't really look for walking, talking aliens that we can hang out with. They focus on finding exoplanets like K2-18b where simple life forms could flourish.
Hey, cheeseheads. Looks like me die horribly again. Make sure to like and subscribe.
Looks like Chase has managed to find alien life. Only now, it's eating his brain.
Oh, man. This hurt. This hurt a lot. This is not fun. My eyeballs are dissolving. No bueno. Hey, this alien talking me. Hey, you know where the sock is? Yeah? Where the socks at? Where the socks?
Yeah, Chase isn't really talking to the aliens. He has a fatal brain fever from inhaling space bacteria, and he's hallucinating. But don't worry, Chase will be back. He always comes back.
635 light years away from Earth, there's a world covered in liquid ocean. A world where you wouldn't die a horrible death. Probably. Welcome to Kepler 22b.
Hey y'all, I've got an exciting mission to land on and explore a planet that could be Earth 2.0. What if guy got tired of sending me to die in the solar system, so this time I'm traveling to an exoplanet where I might actually have a chance to survive. Exoplanets are like planets in our solar system, except they orbit different stars. They're cool, but there's just one problem. Exoplanets are really far away. So your solar system is this tiny little neighborhood with planets and moons orbiting around a sun in its center. And potentially, light years away, there are billions of other tiny little neighborhoods left to be explored. You might have heard of the exoplanet that I'm going to. It's called Kepler-22b, and it's not that far. Okay, only 635 light years. I'll be there in no time.
Even with advanced propulsion technology, a spacecraft traveling at 20% of the speed of light would require 3,175 Earth years to reach Kepler-22b.
Buzzkill. Well, luckily, I'm at a spaceport, and they have this, warp drive technology. So I'll be there in a jiff.
The warp drive technology allows a spaceship to travel faster than light by bending space-time. The warp drive creates a bubble around the ship, moving it through space safely, 99.7% of the time.
Yeah, Rico, technobabble, blah, blah, blah. Never tell me the odds, kid. Let's do this. Well, hello, Kepler.
The Kepler-22 star system is a lot simpler than our solar system. It's only got one exoplanet in it. But this exoplanet, named Kepler-22b, is intriguing. It orbits within the star's habitable zone. And that means one important thing.
Alien civilization.
Water. It means water.
Oh.
Whenever a planet is in the habitable zone of its star, it means that the temperature is warm enough for water to remain in a liquid state, instead of evaporating, like it would, say, on Venus, or freezing like it would on Mars. And the Kepler-22 star is almost exactly like our Sun. It's a slightly smaller G-type star, which means it has a surface temperature of around 5,500 Kelvin. That's 5,200 degrees Celsius. Not too bad for a distant star system, except one thing. This exoplanet, Kepler-22b, is a lot bigger than Earth.
I don't see how that's a problem. It's just more surface to love. I mean, sure, it might have stronger gravity or, like, earthquakes. Kepler quakes? But, like, Earth has earthquakes too, and it's doing just fine.
The larger size of the exoplanet might indicate the presence of a thick atmosphere, leading to high surface pressure. This could result in water existing in a supercritical state, neither a true liquid nor gas, making it less suitable for life as we know it.
It's true, scientists think Kepler-22b might be covered with a liquid ocean, but they can't be sure what that ocean is like. Your mission is to land down there and test the water. And the atmosphere.
Yeah, I was just gonna, land. So, here goes the landing sequence. It's been almost an hour, and all I see is water. Water! Everywhere water! I think I can land here. Seriously, Kepler, you are one disappointing exoplanet. Give up, Rico. Wake me up if you see any land.
My sensors read land right below us. You are cleared for landing.
Seriously? I can't even take a nap. Okay, let's land. this atmosphere is thick. Rico, give me some stats on this planet.
Kepler-22b is a super-Earth, 2.1 times larger and 9.1 times more massive than Earth. It has an orbital period of 289.9 Earth days. It also has water.
Oh, does it? Does it have water? Oh God, thank you so much, Rico. You know, the atmosphere actually kind of looks breathable too. You know, this started out super annoying, but this is actually kind of cool.
Analyzing Kepler-22b atmosphere.
You do that. I'm gonna go see what's out there. Interesting. Oh. That feels nice. I can go skinny dipping in here.
That would violate YouTube's terms of service.
Not if it's a music video, technically. Oh, Rico, what's the temperature out here? I'm starting to feel like some warm bread in a toaster. Toasty.
The equilibrium temperature on Kepler-22b is estimated to be 22 degrees Celsius. However, my sensors pick up a much higher surface temperature.
If Kepler-22b has a thick atmosphere, it would cover the planet like a blanket, heating it up and turning it into an exoplanetary Venus. If the temperature becomes too high, all the water will turn into vapor and Kepler-22b will stop being a habitable world. On the other hand, if Kepler has no atmosphere, well, it might become a frozen world. It would be incredibly cold at night because with no atmosphere, there would be nothing to retain the heat from the day.
That sounds just like Mercury. Not my favorite planet. My favorite planet is Uranus. Kepler-22b, it seems okay. It's a little tough to walk here.
The surface gravity on Kepler-22b is approximately 2.07 times the gravity of Earth.
Yeah, thanks. I noticed that one, Rico. Hey, have you analyzed the atmosphere yet?
Analysis in process.
Oh, so the answer was no. You're still okay.
The thick atmosphere of Kepler-22b likely contains high levels of hydrogen and helium. Those are two gases that are common on larger planets. But if there isn't any oxygen in the atmosphere, you wouldn't be able to breathe. What you should also worry about is the water. It could be acidic or contaminated with toxic elements like heavy metals. Exposure to the body could prove fatal.
Great. So, there's water on Kepler-22b, not that I can drink it, and the atmosphere's in place, and the temperature's all right. What am I missing? Where's all the life?
If life exists on Kepler, it might be microbial. You wouldn't be able to see it without special equipment.
Did you hear that?
My scans are not picking up any life forms.
I gotta check this out. I just need a break first. All this walking around makes me sore. I gotta sit down for a second. I just need to catch my breath.
The atmosphere analysis is not complete.
It's okay. 1 second's not gonna kill me.
Analysis complete.
Something's wrong.
The atmosphere caused your lungs to collapse as a result of barotrauma.
Okay. Thank you.
It looks like the sudden increase in pressure forced the air in Chase's lungs to compress and rupture. One internal organ failure after another, and just like that, he's gone. But don't worry, he'll show up for his next adventure.
Just 4 light years away from Earth sits the closest exoplanet that scientists have discovered, Proxima Centauri b. And it could be the first exoplanet where we find extraterrestrial life. Who better to check it out than our interstellar teammate, Chase?
Yeah, it's true I've died on every exoplanet I visited, but this time will be different.
Your death count is well above average.
Yeah, but Proxima Centauri b has to work out. It's gonna work out. It's literally so close to Earth that I could DoorDash my tuna pizza order, like regular. Plus, the whole system is moving closer to Earth, so in 30,000 years, this whole thing is gonna be 3 light years away.
The bad news is, after another few thousand years, Proxima Centauri b will move further away from Earth, and HH Andromeda will become Earth's closest star, besides the Sun. And unfortunately, that star doesn't have any planets.
Ugh, why do you have to be such a bummer all the time?
Even though Proxima Centauri b is in the closest star system to us, it's still far away. If you left Earth today, you'd reach the Alpha Centauri star system in some 165,000 years, give or take.
Oh, look, we're almost there. You can see all 3 stars from here.
That's right, Proxima Centauri b orbits one star called Proxima Centauri, and this star is part of the Alpha Centauri star system that has not 1, not 2, but 3 suns.
There's Alpha Centauri A and B. Those orbit quite close to each other. And there's Proxima Centauri. So that orbit's much further away, but they're all gravitationally bound together. It's kind of like how Rico and I are 2 peas in a pod. We're just really close and cool guys together. And Peter, he's just around, you know? And we'd like him to stay all the way over there.
Computers have no loyalties or emotional affiliations.
Wow, Rico, ouch. Whatever, man, just initiate landing on Proxima Centauri b. All right. Oh man, this is sweet.
Proxima Centauri b is located in the habitable zone of its host star, but just because it's in the habitable zone doesn't mean it's habitable.
Yeah, just because it's in the habitable zone doesn't mean it's habitable, and just because I die on a planet doesn't mean it's not habitable. Keep up, people.
Though he could have said it better, Chase isn't wrong. Proxima Centauri is a red dwarf star, which makes it very different from the Earth's sun. As a red dwarf, it's much smaller and cooler. It's also a lot more efficient at burning through all of its hydrogen supply. And that means that Proxima Centauri has a lot longer lifespan than the Sun. This red dwarf will shine steadily for trillions of years, long after the Sun runs out of hydrogen and swells into a red giant.
Oh yeah. In 5 billion years, when all these little Earthlings die off because of an apocalyptic sun explosion, I'll be up here chilling like a villain for another 4 trillion years. Yeah.
Well, Proxima Centauri b might not be the best place to chill. Its star, Proxima Centauri, only gives off about 0.1% of the sun's brightness. That means that Proxima Centauri b has to orbit much closer to its star to get enough energy to potentially support life. And being too close to a red dwarf star comes with some dangerous consequences.
Ugh, don't tell me. The solar flares? I always forget about the solar flares.
That's right. This red dwarf star gives off deadly, unpredictable blasts of extreme radiation. These eruptions carry so much energy that they could strip away the planet's atmosphere.
No! Why? No! Why does everything always have to have a downside? No! Oh, why can't life just be good for once?
Ultraviolet bursts from the red dwarf star strip electrons from the particles in the planet's atmosphere. As more and more negative electrons escape into space, they pull the positive ions with them too. This constant escape act strips away most of the atmosphere, leaving the planet with barely any gas to hold on to.
Well, if that's true, this might not be that habitable after all. Rico, let's get an atmospheric reading.
Sampling. Calculating. Thin atmosphere detected. Trace amounts of carbon dioxide, methane, and nitrogen.
All right, well, let's explore a little, see if we can find some water, maybe a place to build a shelter. I can still turn this rock into a home.
Proxima Centauri b has another dark secret. It's tidally locked with its star, which means the planet rotates at the exact same rate that it orbits around Proxima Centauri. Only one side of Proxima Centauri b is facing its star, and that side is forever exposed to light. The other side, shrouded in endless darkness.
Well, that's pretty dramatic, right? I have to choose my spot carefully. Do I want to be a lecherous creature of the night or a wholesome daytime guy? All year round seasonal depression or chronic sunburn? Partied up rave style or read a book sometimes? Tough one. Oh man, this is tough. Oh, I know. I'll live in the Terminator zone.
The Terminator zone is the area between the day side and the night side of a planet. Earth has one too, but it's constantly moving. On a tidally locked planet like this one, the Terminator zone stays in place.
It should have a more moderate temperature and easy access to both sides of the planet. It may also be where I can find water, and don't even get me started on the fact that the Terminator zone is the most habitable place on this whole planet. Just doesn't make sense. Terminator zone. Hasta la vista, baby. Who is your daddy? What does he do? Get to the chopper. Get to the chopper! Get to the chopper!
Arrived at the Terminator zone.
The Earth's Terminator, or Twilight Zone, stretches around 60 kilometers. Now, if Proxima Centauri b has a thin atmosphere, its Twilight Zone would be a little smaller.
Still good enough to build my shelter. All right, let's get to work. I'm making all of this radiation proof. You know, with the amount of UV this guy's blasting off, we have to insulate everything.
Of course, no one has ever been to Proxima Centauri b to confirm if it has an atmosphere and what that atmosphere is like. To find out the atmosphere of distant planets, scientists use a method called transit spectroscopy. When a planet crosses in front of its star, some of the star's light passes through the planet's atmosphere. By studying the changes in that light, astronomers can determine which gases are present in a planet's atmosphere. And we can do that from Earth. It's pretty cool. But transit spectroscopy doesn't work on all exoplanets, and it doesn't work for Proxima Centauri b because this exoplanet doesn't transit its star in a way we can study it from here. If Proxima Centauri b doesn't have an atmosphere, well, it could have a surface temperature of minus 40 degrees Celsius. If it does have an atmosphere, well, then it could be as warm as 30 degrees Celsius. This would be great news because that would mean that Proxima Centauri b could sustain liquid water on its surface. And where there's liquid water, there could be life.
Oh man, this is hard work. I'm getting really hot in here. I'm gonna take a quick trip over to the night zone, you know, cool off a little bit, have myself a little cocktail, see if there's any space ladies over there. Okay, well, I cooled off. I don't know where I am. It's super dark over here, and I can't see, anything. Rico, can you direct me back to the Terminator Zone, please?
The Terminator Zone is 5 kilometers north.
Okay. Which way is north, Rico? I can't see anything. Which way is north, Rico? I don't have a map. I can't see anything. There's no rocks. There's no sun. Which way is north, Rico? You know, I'm gonna reprogram you when I get back to the spaceship. I'm gonna make you not such a loser. You know what Rico probably stands for? Really annoying. Help? Anyone? Rico? Peter? Ugh, even he's not answering? Alright guys, get in the comments. Figure out which way is north, okay? I can tell you that this way isn't north, so help! Okay. Let's try this way.
Well, it looks like we lost Chase to the darkness of Proxima Centauri B. Which is too bad. He doesn't actually come back unless he dies.
Oh God, I made it. Oh, I thought I was doomed back there, stuck to wander in some sick cosmic purgatory for all my life. Oh, I need to take some sort of daytime mental health break. Rico, get me my relaxing chair. Oh, that's beautiful.
He should have stayed in the Terminator Zone. A blast like that straight to the face? The heat and radiation would cook your insides in a second. Looks like Proxima Centauri B isn't as promising of an exoplanet. But don't worry, Chase will be back. He always comes back.
40 light years from us, there's a world that looks a lot like Venus. Only, unlike the most sweltering, hellish planet in the solar system, this not-so-distant planet could actually be the next Earth. This world is called Gliese 12b.
That's right, I'm venturing out of the solar system to find an exoplanet that I won't die on. And yeah, I know I've said that before, but I'm feeling much better about Gliese 12b. Way better than Kepler 22b. I mean, it's like 595 light years closer to this solar system, and all stars and no weight make Chase a happy boy.
Estimated travel time, 200 years.
Okay, that's longer than I expected.
Location, Pisces constellation.
Yeah, so Gliese 12b orbits this red dwarf star in the Pisces constellation, which means the planet is creative, compassionate, intuitive. Unless Pisces is placed in the 7th house, then it's bad at communication.
Chase, astrology doesn't apply to planets.
That's really naive what-if guy. I mean, Saturn literally has a ring on it. Go, girl.
Saturn is a gas giant, and it has many rings.
You know, not everybody's as into monogamy as you are, Rico, okay? And you always take his side. What's going on? Did I program you this way? Whatever, I'll get over it. Rico, now's the time for my favorite phrase. Initiate landing sequence. That really should be my catchphrase. What do y'all think?
Very little is known about Gliese 12b because exoplanets don't emit any detectable light, making it very hard for scientists to observe them. Still, scientists can deduce some basic characteristics using the Transiting Exoplanet Survey Satellite, otherwise known as TESS. This satellite stares at the sky and measures the changing brightness of a star in 20-second to 30-minute intervals as the exoplanet passes the star it orbits.
Hey, we don't need a satellite for that. I can stare at the sky with my own blinky balls.
If only it was that easy.
Oh, man, I almost had it. Oh, now everything has a big red circle in the middle.
Well, nice try. Unfortunately, TESS can only give us data on exoplanets that pass between their star and Earth. Fortunately, Gliese 12b does just that. So this is how we know that it's roughly the same size as Earth, but is about 15 times closer to its star.
Huh. Rico, give me the stats on this red dwarf.
Loading stats.
At what point did this red dwarf make its way to Mordor? Well, Gliese might be orbiting real close to its star, but like the space gods, it's only about a quarter the size of Earth's sun. And with only 60% of the surface temperature? Yeah, Chase can live with that. You know, if this planet's sun had anywhere near the size and heat of Earth's sun, I'd be dead already. I'd be a ball of flame. And my personal preference is to not be a ball of flame.
Correct. Because of its proximity, Gliese 12b receives 1.6 times more energy from its star than Earth does from the sun.
Oh, yeah, we could put a solar panel over here. And here. And over here. You know, this could be the first fully renewable planet in the cosmos. Well, that we know of, at least. Oh, it's a bit warm here. Rico, what's the temperature reading?
62.2 degrees Celsius.
Oh, okay. Oh, man, I'd be worried about bringing you humans to this planet. I mean, you've done a great job heating up Earth already, pumping those greenhouse gases into the atmosphere. This planet is 62 degrees already, so clean energy only here, period. I'm looking at you, Kyle. Yeah, oh yeah. We just cover this whole section with solar panels. This would be really nice. Put a little sofa over there.
Well, scientists haven't been able to collect any data about Gliese 12b's atmosphere. We don't know how the planet would change with any additional gas emissions.
Well, not a problem. Rico, give me an atmospheric reading. Stat.
Calculating. Atmosphere composition is 52% carbon dioxide, 44% nitrogen, 3% miscellaneous gases.
Yeah, alright. Well, all that CO2 explains the heat. If Gliese 12b had no atmosphere at all, it'd be around 42 degrees. And if we had any more CO2, we'd be getting up to Venus temperatures. That would not be pleasant.
Scientists have only observed a rocky surface on Gliese 12b, but since it's in the habitable zone of a star, it could very well have water. Chase, mind doing some exploring?
Yeah, I'll look for some water. I mean, I'm thirsty anyways. And another thing that's important to know before any of you guys move here is that this planet orbits the star every 12.8 days. Do you understand the severity of what that means? Yeah, a New Year's resolution every 13 days. My resolution last year was to sign up for the What If Explorers Club on Patreon. That was an easy one. Hey, that should be your resolution too.
Gliese 12b has almost 4 times the Earth's mass. That means that even though it's the same size as Earth, its gravitational pull is much stronger.
You know, it is a lot harder to walk here now. You know, not that what if guy would think to ask. Still no signs of water. Rico, scan the surroundings for water.
Scanning.
Toot toot.
Movement detected.
What? Movement detected? You mean we're not alone out here? Oh, no. We don't know what this thing is. It could have big claws, big teeth, or worse, big feet. Oh, I hate feet. Oh. Hey there, little guy. You're okay. Your feet are an average size. Ah! Oh! I'm scared. Not scared. I just got something in my throat. Okay, animal life on Gliese 12b? That means surely there must be water here somewhere. Rico, track that animal. We're gonna follow it to a water source. Where did it go? Ah, crap. You know, Rico, while you're tracking that little dude, scan for other alien life.
None detected within a 10-kilometer radius.
Oh man, hope this little guy isn't alone out here. That'd be so sad. Imagine being trapped on an exoplanet all by yourself, the only multicellular organism. At least I have Rico, when he's not malfunctioning, which is most of the time. So I guess me and this critter have a lot in common.
Affirmative.
You know what? You don't have to be alone out here anymore, little guy. I'm naming you Charlie, and you're coming with me. Chasing Charlie, exploring the universe. Oh yeah, I like that song. Come here, little buddy. Come here. Yeah. Oh, come on, you like the sound of that. Sing it with me. Chasing Charlie, come back here. Come back here. Come here, little buddy. Come here. Ow! Charlie, you bit my finger!
Suit decompressing.
Oh no! You stupid stock website 3D animation! No! Damn this stupid planet! I was so close! You stupid red dwarf stone! Suck it, Charlie.
Looks like there wasn't any oxygen in the atmosphere for Chase to breathe. But don't worry, he goes on these adventures all the time, dies, and somehow he always comes back. And little Charlie there gets to continue roaming Gliese 12b a free agent. We'll see if Chase finds any more pets on his next adventure.
Unlike Earth, which is orbiting the Sun, there are billions of rogue planets roaming the Milky Way, not bound to any host star. One of them has been spotted on the edge of our solar system. What if this interstellar object swung through it? How would this space invader affect the orbits of the planets? Could it possibly push Earth out of the habitable zone? This is What If, and here's what would happen if a rogue planet entered our solar system. If a planet doesn't belong to any star system, it's considered a rogue planet. This is an interstellar planet with a catchy name, just 20 light years away from us. It's nearly 17,000 times the size of Earth and has a powerful magnetic field that makes the planet glow with incredible auroras. What if this massive alien planet trespassed the borders of our solar system? Would this mean the end of life here on Earth? Once the interstellar planet invaded our solar system, things could go very wrong. This rogue planet would likely be moving at hundreds of kilometers per second. If we were unlucky enough to be on a collision course with this massive alien object, the Earth would be completely demolished. But don't worry, our solar system is quite big, and the chances of the rogue planet bypassing us without a fatal collision are pretty high. Instead, our interstellar guest would be busy disturbing the orbits of all the planets in the solar system. That's because a rogue planet nearly 13 times bigger than Jupiter would have a huge gravitational impact, making other planets' orbits, including Earth's, more elliptical. And that's when the bad news begins for life here on Earth. The Earth is orbiting the Sun's relatively narrow habitable zone. Within this zone, also known as the Goldilocks zone, it's not too cold, so our water doesn't turn to ice, and not too hot, so it doesn't get vaporized, and neither do we. Just perfect. Change the Earth's orbit, and the conditions for life won't be so great. The rogue planet may not push us out of the habitable zone, but it would bring us much closer to the Sun for very short and exceptionally hot summers. Those extreme summers would be followed by long and super cold winters. Quick summers would leave us less time to grow crops. By the end of our first never-ending winter, humanity could face food shortages, even extinction. The Earth might be thrown into the next ice age. Instead of global warming, we'd be worried about global cooling. We'd rethink our energy sources and try to pump out more greenhouse gases to warm the planet up a little. Solar energy, on the other hand, would be considered very inefficient in the wintertime, but could be used very effectively during the short blaze of summer. Count on things being much worse if the Earth gets knocked out of the habitable zone. At that point, the Earth would considerably cool down. All our water would freeze, and so would we. This would be the end of most life on Earth. The only way we could survive would be if we learned to live at the bottom of the ocean, next to deep-sea thermal vents that push out extremely hot water. Maybe eventually we'd evolve into a different life form that would take control over the frozen planet. Lucky for us, the universe is enormous. There's a lot of space between rogue planets and other objects in our galaxy, and that makes this scenario very unlikely.
Could there be an even better planet for us than Earth? Scientists are searching for a super habitable world that wouldn't just rival Earth, but be a place where life could thrive even more easily. And they're looking at exoplanets. How would we discover Earth 2.0? What would make an exoplanet habitable? And how long would it take to get there? This is What If, and here's what would happen if we discovered Earth 2.0. You wouldn't be able to find an exoplanet by looking through a telescope. All you'd see is the bright glare of the stars they orbit. NASA built the Kepler telescope to discover exoplanets. And before it ran out of fuel, the Kepler telescope surveyed our region of the Milky Way galaxy. Its technology uses the transit method to find planets hundreds of light years away. How? It measured the fluctuation of light coming from distant stars. When a planet transits or passes in front of a star, the star isn't as bright, so the Kepler telescope uses that to detect exoplanets. This is not an easy thing to do, but during its 9-year lifetime, the Kepler telescope confirmed the existence of 4,367 exoplanets. Could any of them be Earth 2.0? If you're a longtime fan of What If, you've probably heard this before, but Earth is a very special place. And even if a planet is deemed to be habitable, it doesn't mean that it resembles Earth very much. A habitable planet is a rocky planet located in the habitable zone, allowing water to stay on the planet's surface in its liquid form. That's it. Venus and Mars are habitable planets, but they are definitely not like Earth. So let's talk about 3 major conditions that we'd look for when searching for an even better version of Earth. First, it would need to have sunlight. Our sun's lifespan is about 10 billion years, and it took 4 billion years for anything more complex than the simplest life form to pop up on our planet. But K-type dwarf stars have lifespans of about 70 billion years, so if we found an exoplanet orbiting a K-type star, there would be more time for life to evolve and live on it. The second major condition is temperature. a planet that's too hot or too cold wouldn't be able to host the life forms we'd need to survive. But if we find a planet that's a mere 5 degrees warmer than Earth, and it has more water, we could be looking at Earth 2.0, covered in a lush, biodiverse rainforest. The third major condition we'd be looking for is size. Gravity retains a planet's atmosphere, and there's a direct relationship between gravity and a planet's size. So, if we find a planet that's only 1.5 times larger than Earth, it would be able to hold on to its interior heat and maintain its atmosphere for a longer time. But bigger isn't always better. While Earth-sized exoplanets are usually rocky, about 50% of the exoplanets larger than Earth are gas giants. And if an exoplanet is too small, it would likely be barren, like Mars. So, are there any exoplanets out there that meet these requirements? Okay, I found a planet that could be super habitable. Kepler 1649c could be a contender to become Earth 2.0. It's 300 light-years away and orbits a red dwarf star. It gets sunlight, but only 75% as much as Earth, so it might be a bit cooler there. And there wouldn't be any seasons on Kepler 1649c. A full orbit only takes 19.5 Earth days, so we'd need to get used to that. Oh, and it could be tidally locked, which means one side of the planet constantly faces its sun, while the other side faces space. Also, living on a planet that orbits a red dwarf star could be risky. Sometimes red dwarf stars send out massive flares, dousing an orbiting planet in UV light and creating huge temperature fluctuations. But if we decide that Kepler 1649c is worthy of becoming Earth 2.0, what would happen next? Well, using our current technology, it would take at least 2,000 years to reach this Earth 2.0. And since this planet is so far away, we only know about its size, the distance to its star, and the makeup of its atmosphere. So we could pack up humanity, take the multi-generational trip to Earth 2.0, and discover that it's more like a Neptune 2.0. Yeah, there's no way we could survive on a gas giant. We'd need much more information before we send humans to any possible Earth 2.0s. So, right now, NASA is developing a tiny probe to travel at 1/5 of the speed of light. It could greatly expand our knowledge of exoplanets. And we shouldn't limit ourselves to looking just at exoplanets. A moon receives direct solar energy from its star, and the planet it orbits reflects solar energy toward it. So maybe a moon could be more suitable for human life than an exoplanet. The most Earth-like planet in our solar system is Titan, Saturn's largest moon. So if we want to save thousands of years of traveling, maybe Titan could make a good second home for us. 635 light-years from where you are sitting, way out there in outer space, lies a planet. The first planet to be discovered within the habitable zone of a sun-like star. Its name is Kepler 22b. When a planet is located within a star's habitable zone, it means there's a chance that liquid water exists on its surface. And where there's water, there's also the possibility of life. Human life. How long would it take to get to Kepler 22b? What would the weather be like over there? And why would you need to get jacked before arriving on this new planet? This is What If, and here's what would happen if you lived on Kepler 22b.
Kepler-22b is what scientists call an exoplanet. It's a planet outside our solar system. Spotting an exoplanet like Kepler-22b is often not easy. The bright glare of the stars they orbit tends to keep them hidden from our telescopes. What did scientists come up with to get around it? Looking at the stars themselves to see if they can find anything unusual about them. They spotted Kepler-22b using what's called the transit method. They watched Kepler-22, the star this exoplanet orbits around, and noticed that its brightness changes over time. That was because Kepler-22b was blocking the star's light. With this, scientists were able to learn both the size of 22b and how it orbits. And it looks like this distant space rock could become our next home. Okay, but what do we really know about Kepler-22b? Its mass is 36 times that of Earth, with a radius of 2.5 times larger than ours. 1 year on Kepler-22b is 290 days. It's also located 15% closer to its star than we are to the Sun. If Earth scooched over that close to our star, you'd be fried. Kepler-22b, on the other hand, is lucky to have a sun that is remarkably similar to ours, but also smaller and cooler. This close proximity to its star allows the planet to receive about the same amount of sunlight as we get over here. The temperature on Kepler-22b could be about 15 to 22 degrees Celsius. Similar to Earth's spring weather, and quite habitable if you ask me. But our galaxy can be a cruel place, and not everything is good news. Some models suggest Kepler-22b is rotating on its side, kind of like our very own Uranus. This may sound insignificant, but it adds potentially deadly complications. This would mean that its north and south poles are shrouded in either darkness or sunlight for half a year. And this ain't simply a matter of whether you're a daytime or a nighttime person. A world like Kepler-22b spinning on its side means that temperatures could change from boiling to freezing, which wouldn't be great for human life. I know, what a bummer, but don't despair yet, because our galaxy is also big enough to include some hope. New studies suggest that Kepler-22b might be covered in an ocean 50 meters deep, and that ocean would be able to act as natural climate control, keeping the wild temperatures at bay. You see, an ocean can store heat in the summer and release it during the winter, which results in a mild climate. Like you needed another reason to live close to the water. But hold on, how would you even make it all the way to Kepler-22b? I mean, even if you were traveling at the speed of light, it would take you 635 years. Your best bet could be to hibernate through the trip inside a device that preserves your body way past its natural lifespan, like cryogenic sleep. NASA has already developed a cryosleep chamber that can lower an astronaut's body temperature to as low as 32 degrees Celsius. This would trigger natural hibernation, during which catheters would provide your body with nutrients and remove any waste. But even in cryosleep, it would be quite the long, risky trip. This leads us to the most dangerous part about this journey. All that remains unknown about Kepler-22b. For starters, we still don't really know what gravity is like there. It could be twice as strong as our planet's. If that was the case, a 10-kilogram sack of potatoes would now weigh 20 kilograms. And your body would also factor into the mix. Is your current weight 75 kilograms? Well, good luck suddenly dealing with 150 kilograms of you. And just for safety, settlers such as yourself would need to bulk up. Really bulk up. Only through intense strength training would you increase your chances of being able to walk on Kepler-22b. And once you got jacked on Earth, you'd have to figure out ways to preserve that muscle through all 635 years of light-speed travel. But humans aren't the only life form that would be affected by a stronger gravity. Plants brought from Earth for oxygen and nutrition might not survive on Kepler-22b when you try growing them there. And if you brought any animals with you, they'd need to step up the evolution process. Higher gravity could lead to creatures developing additional legs to move around. It could also determine the location and size of internal organs. But the mysteries don't end there. Scientists still don't know for sure that Kepler-22b is even a rocky planet. It might be gaseous, similar to Neptune, or it could be entirely covered with water. If you and the other first settlers woke up from your cryosleep and found yourself on a gas planet, yeah, that would be a downer. You wouldn't have a solid surface to even land your ship, not to mention a place to set up camp. In that case, you and your crew would need to figure out how to build a cloud city orbiting the planet. If you landed on an ocean planet, a submarine town would be in order. Discovering Kepler-22b is a rocky planet would be hitting the jackpot then, right? Well, not so fast. Venus is also made of rock, and yet its dense atmosphere, consisting of greenhouse gases, makes it uninhabitable, with scorching temperatures far too hot for liquid water. If this was also the situation with Kepler-22b, our only chance at thriving on this exoplanet would be to employ robots that could build underground shelters. The place where maybe, just maybe, the temperature might be cool enough for you to bear. It just goes to show you that a prime location is no guarantee for human survival. And as exciting as it might seem to find other worlds to inhabit, our own Earth remains the perfect habitat for humanity. But
This blue marble-like planet looks just like Earth, but only 5 seconds on this hostile death orb would kill you. Welcome to HD 189733b. This planet is enormous, even larger than Jupiter. And to keep comparing it to the largest planet in our solar system, it's also entirely made of gas. That's why scientists classify HD 189733b as a hot Jupiter. This planet is located so close to its star that it completes its orbit in just over 2 days. Yeah, HD 189733b is 13 times closer to its sun than Mercury is to our sun. And even though its star is cooler than ours, this fake Earth is still way outside its star system's habitable zone. That means no liquid water can exist on a planet's surface. Just how this giant gaseous planet developed so close to its star is still a mystery. One theory is that HD 189733b formed right next to it during the star's earliest moments. Or it could have developed further away, only to be pulled in as the rest of the planetary system formed. But there's one thing we know for sure. A visit to HD 189733b would be a plunge into hell with no chance of escape. Now, even if you knew there wasn't a single drop of liquid water on this planet, you'd have a hard time believing it as you approached the giant blue marble. With an average daytime temperature of nearly 1100 degrees Celsius, this planet is twice as hot as Venus, and Venus is the hottest planet in our solar system. One of the reasons for this intense heat is that the planet is tidally locked to its star, just like our own moon is to Earth. That means HD 189733b takes as much time to spin on its axis as it does to revolve around the star. So one side of the planet is constantly in daylight, while the other side is shrouded in darkness. The inviting look of this world doesn't come from its oceans like it does here on Earth. No, this hellish planet gets its color from clouds of molten silicate particles. These particles scatter more blue light than red, making the planet appear blue. Silica is the primary ingredient in glass, and you should bring a heavy-duty umbrella because you'd need to take cover from what would essentially be hot, molten glass rainstorms. But that's not the only danger. You'd need to be ready to brace yourself against the extremely powerful winds that you'd find sweeping across the planet. With speeds up to 7,000 kilometers per hour, these gusts are almost 30 times stronger than even the most powerful Category 5 hurricanes on Earth. Compared to the strongest winds on other planets in our solar system, HD's winds are almost 4 times stronger than those on Neptune. But hey, they might smell a little better than the ice giant's hydrogen sulfide clouds. Those carry a whiff of rotten eggs. HD's winds are so fast that they'd whip past you at about 6 times faster than the speed of sound. They would be extremely loud, but I think you'd be more worried about them tearing your body apart. You might be long gone by now, killed by that molten glass rain. In any case, you wouldn't last too long on HD 189733b. I really don't recommend traveling there. But there are some planets out there that can kill you even faster. Check out OGLE TR56b. This gas giant sits in a galaxy nearly 100 light-years away from Earth. It's even larger than HD. Its mass is nearly 1.4 times as much as Jupiter's, and somehow it's even closer to its star, too. You'd find this world to be incredibly scorching hot. Surface temperatures on this planet average around 1,700 degrees Celsius. That's so hot that it turns metal to gas, creating iron clouds in the upper atmosphere. If you got caught in the rain here, you'd find it to be an extremely unpleasant and deadly shower of hot molten iron. Your skin would burn right off, and so would your insides. But things could get even hotter. Some 670 light-years away from Earth, there's a planet so hellish that it's tearing molecules apart. Meet K2-9b. This gas giant is almost 3 times more massive than Jupiter. It takes Kelt only 1.5 Earth days to speed through the orbit around its sun. And just like HD 189733b, it's tidally locked, with one side always facing the hot star. Landing on this planet, you'd experience temperatures as high as 4,300 degrees Celsius. It's the most scorching exoplanet we've ever discovered. Scientists call this gas giant an ultra-hot Jupiter. And those high temperatures also make K2-9b hotter than most stars in the universe. So hot that it would destroy you. Come on, this world rips apart molecular hydrogen gas. What do you think it would do to your body? But before you even arrive on this hot planet, you'd be exposed to deadly amounts of radiation coming from its host sun. Yeah, K2-9b receives about 44,000 times more energy from its star than Earth does from the sun. This radiation would cook you alive instantly. Okay, if you somehow managed to survive all the lethal radiation of Kelt's star and the unimaginable heat of the planet, well, you'd still have to take on its incredibly strong winds. Scientists think those winds could reach speeds of 60 kilometers per second. Yeah, that's 30 times faster than the winds on the deceivingly Earth-looking planet HD 189733b. Okay, so if I get this straight, K2-9b would swirl you, burn you, and tear your molecules apart.
1 out of 10. Would not recommend.
Thousands of light years from Earth, there could be another planet hospitable to life. Kepler-69c. And you're about to travel to this alien world to see that life with your own eyes. What would it be like to make this epic journey so far across the universe? What kind of planet would you be likely to find upon arrival? And if you did discover life, what would it look like? This is What If, and here's what would happen if there's life on Kepler-69c. Located 2,383 light-years from Earth in the Cygnus constellation is a potential super-Earth. At least that's what it's often referred to as. Kepler-69c is an exoplanet about 1.7 times larger than our planet. And it could also be around 3.5 times more massive. But there's a catch. We don't really know if this planet is located within the habitable zone of its star. If it's too close, Kepler-69c would be too hot for liquid water to exist on its surface. If it's too far from its sun, well, then it would be nothing more than a frigid world. What we do know is that Kepler-69c orbits its star about 40% closer than Earth orbits the sun. And that could mean that it isn't actually a super Earth. It could be a super Venus. So, if you traveled all the way here, would you find life? Or a thick, scorching atmosphere boiling every drop of water on the planet? Before you begin your journey to Kepler-69c, there'd be one very important thing to keep in mind. It's far away. Almost 600 times further away than Proxima Centauri, our closest neighboring star. Even if you could travel, say, 1% of the speed of light, you wouldn't get there anytime soon. At this speed, you could whip around Earth in just over 13 seconds, but to get to Kepler-69c, well, that would take you about 238,000 years. To even make this trip possible, you'd need a super advanced hibernation pod. You know, you don't want to grow too old and die before you could even get to your destination. Am I right? Well, hibernation technology that could help you sleep for over 200,000 years doesn't exist yet, but hey, this is what if. Anything's possible. By the time your ship makes its arrival, any life that may exist on Kepler-69c today could evolve or advance into something entirely different. Think about it this way. 300,000 years ago, humans were just beginning to create stone tools and spears. And look at you now, making a trip across the galaxy. Looking back at the planet you left behind, who knows what changes would happen to our human civilization during your trip? No matter what, it's way too late to turn around now. Based on the planet's distance from its star, we know that Kepler-69c receives a similar amount of sunlight as Venus. And despite being more massive than Earth, it has a relatively low density. All this means is that instead of metals, this rocky planet is made of silicate and carbonate minerals. That could make things a little complicated. You see, with all these minerals in the crust, Kepler-69c could have a really thick atmosphere. And to make matters worse, this atmosphere would be composed mostly of carbon dioxide. Uh-oh, did you choose the wrong super-Earth to travel to? Yeah, if Kepler-69c is anything like Venus, it would be a pretty hot planet. All because, similar to Venus, its clouds would trap the heat and create an extreme greenhouse effect. Kepler-69c's atmosphere would be caught in an endless cycle of getting thicker and hotter. But nobody said this world should be habitable for you. Oh no, once you took off your helmet, you'd instantly melt and suffocate. Like I said, life on this planet would be completely different from what you'd imagine. As you made your approach, you'd find surface temperatures as high as 475 degrees Celsius, and the atmospheric pressure would be over 90 times that of Earth at sea level. It would be like being 900 meters deep in the ocean, except you'd be on dry land. With conditions like this, you'd likely not find anything resembling an ocean here. Just like on Venus, the high temperatures would boil away all the water. Whatever life you could potentially encounter on this planet, it would need to be able to survive in these brutal conditions. Or it would have to exist somewhere else besides the surface. One place you could discover life on Kepler-69c would be up in the clouds. Around 50 kilometers up, temperatures would be much, much cooler. They would range from about 30 to 70 degrees Celsius. And with its low density, this planet could have a surface gravity that would be just over 70% of what's found on Earth. This weaker gravity could allow life forms to thrive in the sky, where Kepler-69c is most hospitable. Life could just be floating freely in the atmosphere. This would be another way in which this planet could have far more in common with Venus than with Earth. Probes around Venus have picked up traces of a gas that could be a potential sign of life: phosphine. If you discovered phosphine in Kepler-69c's atmosphere, it could be the result of bacteria that don't require oxygen to survive. But be ready to hold your nose. This smelly gas has an odor similar to decaying fish. On Earth, the bacteria that produce phosphine often live in swamps or wetlands, but on Venus or Kepler-69c, this bacteria could exist in the thick, oxygenless atmosphere itself. So, in the end, you may have traveled a very, very long way to find the smallest and stinkiest of life forms. Now, on the upside, you've just discovered extraterrestrial life.
This is a planetary emergency evacuation. Please remain calm and board your space shuttles.
You know, even though humanity might not have to leave the Earth in your lifetime, we should start preparing early on. Not only could it take centuries to set up the relocation program, it would take generations to move to a potential new home. That right there is Proxima Centauri b, or just Proxima b. It's the closest potentially habitable planet out there. Its temperatures are in the bearable range, and it could have just the right breathable atmosphere. We only have to get there. How long would our journey last? How many people would we send to populate the new world successfully? And what if it turned out that Proxima b wasn't as habitable as we thought? This is What If, and here's what would happen if we relocated humanity to Proxima b. When astronomers started finding planets outside our solar system, or exoplanets, we realized that there are many worlds out there. That meant that Earth doesn't have to be our home forever, and that we don't have to die with our planet when the sun engulfs it some 5 billion years from now. Now that we've found over 4,100 exoplanets, we've learned something rather disappointing. Not all exoplanets are good for humans to live on. Most of the worlds we've encountered are either ice giants like Neptune or gas giants like Jupiter and Saturn. Only 161 of those planets are terrestrial, like Earth. And when it comes to sustaining human life, being terrestrial isn't quite enough. Proxima b is very promising. It orbits a red dwarf star called Proxima Centauri in a system with 3 stars in it. Proxima Centauri is small. It only has between 7.5 and 50% of our sun's mass. That's a good thing, because the red dwarf Proxima Centauri is so much smaller than our yellow dwarf sun. It burns at a lower temperature. It takes stars like Proxima Centauri much longer to burn through all of their hydrogen supply. Because of that, Proxima Centauri has a lifetime of trillions of years, while our sun has a 10 billion year expiration term. That alone makes Proxima b a good candidate for relocation. That, and the fact that its orbit lies in Proxima Centauri's habitable zone, that means there's the potential for liquid water and comfortable surface temperatures. If we're lucky, Proxima b would have an atmosphere that we could breathe. If it does, the surface temperatures would be in the range of 30 degrees. I don't know about you, but I'd move there right now. I just need to warn you that there are a few problems. A trip to Proxima b would be long and very dangerous. Proxima b might be the closest habitable exoplanet we've got, but that doesn't mean it's close. The red dwarf star Proxima Centauri is about 4.3 light years away. That means that if you could travel at the speed of light, it would take you 4.3 years to get there. Nothing we've built so far can reach that kind of speed. Realistically, a trip to Proxima Centauri in a space shuttle would take 165,000 years, give or take. That's right. Some of the colonists would be born in transit. Some of them would never see the Earth. Some of them would never see Proxima b. They'd just live their lives aboard the spaceship and die in space. How many humans would we need to send on a mission exactly? Well, according to some calculations, 98 people would be just enough. Their descendants would arrive at Proxima b with enough genetic diversity to populate the entire planet. And that's accounting for possible cases of infertility, inbreeding, and sudden deaths. In those calculations, the crew would be traveling on something faster than a space shuttle. Their mission to Proxima b would only take 6,300 years. But don't be surprised. Technology is constantly improving. Right now, a scientific and technological program called Breakthrough Initiatives is looking at how we can get in the neighborhood of Proxima Centauri within 1 generation. Their Project Starshot is working on an ultralight, unmanned probe that would reach the star system in just 20 years. Now I definitely need to sign up. But again, Proxima b is really far away. It's so far that we can't even see if it has an atmosphere. It might just happen that we would arrive at a frozen planet with surface temperatures of -40 degrees. And even if it has an atmosphere, it might not be the right one. We might still enjoy warm temperatures, but we'd be doing that in spacesuits with oxygen tanks. Or Proxima b could be tidally locked to Proxima Centauri, meaning that one of the planet's sides would always face its star, and the other side would be plunged into darkness. Spaceflight itself could bring some unpleasant surprises. Spending an entire lifetime in a zero-gravity environment would lead the crew members to lose muscle and bone density. They'd be constantly exposed to space radiation. Their microbiomes, immune systems, and physiology would all be different from ours. They wouldn't be the same kind of humans as we are. They would change their values and culture. They might forget all the farming techniques we teach them to sustain themselves in space and on their new planet. They might change their mind about the mission altogether
and just turn their spaceship in a different direction. Who knows? They might even come back to Earth and take revenge for all those years they were forced to spend in space. If that happens, I'll be asking for a refund. Sending anyone on a mission like this is a huge risk. We'd need to design and build a vehicle, choose the space travelers very carefully, supply them with all the food and water, and make sure they could become self-sustaining. We'd have to design new propulsion, navigation, hibernation, and life support systems. And we have no way of knowing if Proxima b is actually habitable. Well, now I don't really feel like going there, do you?
Avatar's Pandora is the wildest, most beautiful, and most deadly place in the galaxy. I mean, who wouldn't want to live here? But how could the air kill you? What elements could make your body glow? And how could a gas giant destroy Pandora's surface? This is What If, and here's what would happen if you lived on Pandora. Welcome to Pandora. Located in the Alpha Centauri star system, this world is shrouded in mystery and the cinematic rules created by James Cameron. For starters, Pandora isn't even a planet. It's a moon of a gas giant just like our Jupiter. If this deadly moon existed in real life, it would have to follow the laws of physics. And that's good news for you because on Pandora, you'd weigh 20% less than you do on Earth. Take advantage of that weaker gravity and leap across the untamed alien jungle. But under no circumstances should you ever jump in this water. The gas giant Pandora revolves around is called Polyphemus. This massive planet is only a bit smaller than Jupiter, but it's big enough to destroy all life on the world you just arrived on. Pandora and Polyphemus are tidally locked, so only one side of this moon is always facing its gas giant. And that's dangerous, because it could cause tidal heating when one side gets a slightly larger gravitational pull than the other. Sure, this could create floating mountains along the magnetic waves of Polyphemus, except Pandora's surface wouldn't be anything like it is in the movie. In reality, it would look more like Jupiter's moon Io, which also happens to be the most volcanically active world in the solar system. And if that wasn't enough, Pandora's sky would be radioactive. Well, sort of. If the magnetosphere of Polyphemus was just as big as Jupiter's, Pandora would be trapped within it. There, it would be bombarded with charged particles from its own star system. If Pandora didn't have its magnetosphere, you'd have no buffer from these intense rays, so you'd better wear a what-if-approved protection suit. And trust us, you would want to have this suit, because even if it wasn't radioactive, the atmosphere would still kill you. On Pandora, the air would be mostly made up of carbon dioxide and xenon. Both of these gases in high concentration would instantly suffocate you. Oh, and that rotten smell? Yeah, that's hydrogen sulfide. It won't kill you, but you'll wish you were dead. You might have to live underground, or maybe even underwater. In Avatar, The Way of the Water, you'll dive under the waters of Pandora, but if this planet existed, the water could kill you. That's because that water would likely be highly acidic, thanks to the high carbon dioxide levels in the atmosphere. It could be so bad, it would dissolve all sea life that has shells. Yeah, and that would severely affect the food chain. Even worse, one dip in these waters could burn your skin off. You'd need to make sure that protection suit was waterproof.
But if you set up your life in the ocean, well, you'd miss the beauty above the surface. Since Pandora and its gas giant are tidally locked, Polyphemus would always be visible in the sky. You would watch Alpha Centauri A rise and set just as our sun does, but Polyphemus would never leave your sight if you were on Pandora's right side. The other side of the moon would never get this magnificent view. This comes with some trade-offs, like you'd have a hard time falling asleep. The Alpha Centauri star system Pandora is located in has not just one, not two, but 3 suns. Pandora would orbit around Alpha Centauri A, but another star, Alpha Centauri B, would also be sending a lot of light Pandora's way. It burns 2,300 times as bright as the full moon on Earth. And you wouldn't even be able to watch Netflix during your sleepless nights. Standard electronics wouldn't last long in this environment, not with all that radiation and electrical interference. You'd need space marine-grade technology to survive in this world. At least there would be enough animals and plants for you to feast on. Only I'd recommend running chemical tests for heavy metals and strong acids before you eat anything. Undetected toxins could destroy your kidneys and liver. And there might be an unexpected side effect. If you ate too much glowing food, you might become bioluminescent. Pandora would be a world of incredible species and extreme wildlife. Hey, soon enough, you might be taming an Ekron for the commute around your strange and lethal home. "120 light years away from us, there's an exoplanet that can potentially host life. It's called K2-18b, and it's a world you'd want to visit. K2-18b isn't exactly like Earth, it's more like a super Earth. Yeah, it's 2.6 times larger and almost 9 times more massive than our planet. Scientists think it could be a Haitian exoplanet, which is just a fancy way of saying that it likely has a hydrogen-rich atmosphere and is covered in liquid ocean. That means that K2-18b could be home to alien life. Only it would take a really long time to get there. If you were hurtling toward this space rock from Earth, you'd reach your destination in about 1.3 million years. Yeah, you heard right. Million. K2-18b has a lot of methane and carbon dioxide in its atmosphere. That's not exactly breathable air, so you'd still need a spacesuit to walk on this world. And I wouldn't be too hyped up about its ocean either. If an exoplanet has liquid on it, it doesn't mean that the liquid is water. It could be methane or ammonia, even acid. Like, even in our own solar system, there's a moon covered in liquid lakes, but these are methane and ethane lakes, and I wouldn't recommend swimming there. K2-18b could have a pretty mild temperature. For an exoplanet, that is. At minus 100 degrees Celsius, you'd find this world incredibly cold. Now, the most exciting thing we've found out about this world is that it could have traces of dimethyl sulfide. Woot woot! Well, on Earth, this molecule can only be produced by living things, and that means K2-18b could be home to alien life. Now, it doesn't mean that this life would be intelligent. It could be aquatic or microbial. Maybe even complex life if the conditions for it are just right. We won't know for sure unless we travel to explore this interstellar world. Now, how do we know all this? Well, we had the James Webb Space Telescope look at this distant world and take detailed measurements of its atmosphere. Most of the exoplanets have been discovered using what's called the transit method.
It's when a planet passes in front of its star and blocks its starlight. That's when scientists study the wavelengths around the planets, and some of those wavelengths can tell us what kind of atmosphere those distant planets have. The problem is, exoplanets are really far away. Trying to figure out what their surfaces are like just by peering through even our most powerful telescopes is not easy. Some scientists will argue that K2-18b isn't a super Earth at all, but a mini Neptune. And that's a bummer because, as you know, Neptune is an ice giant. And if K2-18b is also an ice giant, then the chances for alien life on this planet don't look so good. Now, you don't have a million years to travel to this world to discover it for yourself, so maybe we should look at a world that's a lot closer to Earth. Like Proxima Centauri b. Proxima Centauri is the closest star we've discovered, only 4.2 light years away from Earth. It's part of the Alpha Centauri star system, with not 2 but 3 stars orbiting each other. The exoplanet Proxima Centauri b orbits only one of these stars, but you'll still see the other 2 stars as bright dots in the sky. This exoplanet is slightly larger than Earth and revolves uncomfortably close to its host star. Luckily, that star is a red dwarf, and that's much cooler and smaller than our sun. Which is good news because that means this planet isn't getting toasted like Mercury. Scientists estimate Proxima Centauri b has an average temperature of about minus 39 degrees Celsius. That's pretty comfortable as far as alien worlds go. The bad news is that we still don't know much about the exoplanet's gravity or atmosphere. It might be our best candidate to set up an interstellar base, but it also could have a harsh environment, unsuitable for humanity's future home. It might even have an ocean of acid, or something deadly like that. The only way to find out is to travel there. And if Proxima Centauri b doesn't work out, well, don't worry, there are plenty of potentially habitable worlds out there. Like this one. Ross 128b is 11 light years from Earth. It's the second closest potentially habitable world scientists have discovered. And it's more promising than Proxima Centauri b. The thing is, they both orbit red dwarf stars, only Proxima b's host star is a lot more active and violent. It occasionally erupts and bathes Proxima b in radiation. Ross 128b's star is nice and quiet. And even though this world orbits 20 times closer to its star than Earth is to the Sun, it still lies in the habitable zone. Because like I said, red dwarfs are way cooler than the Sun. And by cooler, I just mean temperature. This world could have a balmy average temperature of 23 degrees Celsius. That's only slightly hotter than the average temperature here on Earth. I don't know about you, but I could settle there. Now, we don't know enough about this world to call it our new home. It likely has lots of harmful radiation reaching its surface, and its atmosphere might not be breathable. But hey, that's not much worse than Mars. With efficient life support systems in place, we could make it work. Besides, this super Earth might have its own life on it. If Ross 128b did have alien life, it could be extremely different from what you might imagine. Just think about making the first contact with an alien species. What would that be like? I mean, it could go very wrong, too. For one, we might not survive the trip to any exoplanets, even the nearest ones. So far, we've discovered and confirmed over 5,000 alien worlds. 63 of them are potentially habitable, but we just can't know for sure. There are hundreds of billions of alien worlds in the Milky Way galaxy. And scientists have already discovered and confirmed over 5,000 of them. They call these worlds exoplanets. Some of them are really small, like Kepler-37b. This tiny planet is even smaller than Mercury, the smallest planet in our solar system. Kepler-37 is just slightly larger than our own moon. It could easily replace our cosmic companion in the night sky. Only it's pretty far from us. This tiny space rock is located 208 light years from Earth, where it orbits a star that's a bit smaller and cooler than our Sun. Small rocky worlds like Kepler-37b are a pretty rare find. Because they're so tiny, they're more difficult to spot, but scientists have still managed to confirm about 200 of these worlds. Most of them are many times closer to their stars than our planet is to the Sun, and Kepler-62c is no exception. This Mars-sized exoplanet orbits its star roughly 4 times closer than Mercury orbits our Sun. It only takes a little over 12 Earth days to make a full orbit. Kepler-62c must be scorching hot and extremely volcanic. Definitely not the kind of place you'd want to visit. And neither is this exoplanet, KOI-55b. Scientists think this planet used to be the size of Jupiter, but then its sun exploded into a red giant and swallowed the planet whole. No surprise there, KOI-55b is incredibly close to its star. So close that it takes this hellish world less than 5 hours to make one orbit. And KOI-55b is evaporating so much that it will soon disappear from its planetary system. It's not alone. Many of these planets have their atmospheres torn away by their host stars. Some 41 light-years from Earth, there's a super-Earth that used to be a mini Neptune. GJ1132b might have had a thick hydrogen atmosphere in the past, but its young hot star stripped it away, leaving only a rocky core behind. When its star stripped away its original atmosphere, some of the gases were absorbed into the planet's mantle, and now, through this planet's volcanism, they're released back. GJ1132b could have become a potentially habitable world, but it's 26 times closer to its star than Mercury is to the Sun. No chances for life on this super-Earth. But life might be possible on these slightly larger super-Earths. Scientists have found many of these worlds orbiting in their sun-like stars' habitable zones. And that's good news. Now, we'd have to go and explore more of these planets up close to find out what their atmospheres are like. This one seems intriguing. Kepler-452b is 1.6 times the size of Earth, and it's about 6 billion years old. Earth is a youngster compared to this world. Our planet is only 4.5 billion years old. Okay, now I know this is your favorite exoplanet, Kepler-22b. And I like it too. This super-Earth might be covered in a super-ocean. It sits comfortably in its star's habitable zone and has a huge potential for life. The only problem is that it's big. Kepler-22b is 2.4 times larger than Earth and about 9 times more massive. If Kepler-22b was the size of Earth, it would have an average surface temperature of about 16 degrees Celsius. But because it's a lot bigger than Earth, it could be a rocky planet, a water world, or even a gaseous planet like Neptune. And speaking of gaseous planets, at this size, exoplanets stop being super-Earths and become gas giants. More than half of all exoplanets we've discovered are either Neptune-like ice giants or gas giants like Jupiter. Many of them orbit a little too close to their host stars, and they pay a high price for that proximity. For one, they're incredibly hot, and sometimes their host star rips their atmosphere away. Kinda like what GJ1132b went through. But among them, there are some cold planets too. Oof! This is Kepler-16b. It's not quite as large as Jupiter, but the cool thing about it is that it orbits not one, but two stars. Only you wouldn't be able to see those stars because you wouldn't be able to stand on its surface. You see, Kepler-16b is a Saturn-sized gas giant. It might have some rocky elements inside it, but its two host stars are much cooler than our Sun, making Kepler-16b a frigid, lifeless world.
Okay, now on to the worlds that are bigger than Jupiter. This delicious exoplanet has the density of a marshmallow. TOI 3757b is slightly larger than Jupiter, but it's not nearly as massive. But there are always bigger and badder planets out there, like Kepler-7b.
This one is interesting. Kepler-7b is larger than Jupiter, but it has half of Jupiter's mass. This means the planet is like a super light cloud, a scorching hot super light cloud. Kepler-7b is a hot Jupiter planet. It's 12 times hotter than the king of the solar system.
Still, Kepler-7b is not the hottest or the weirdest of the exoplanets. Some of these gas giants are so unimaginably hot that they tear molecules apart. Yeah, and some planets are just doomed. 1,400 light years away from Earth, a star slightly bigger and hotter than our Sun is devouring its planet.
This planet is called WASP-12b. It's almost double the size of Jupiter, but it's not going to last very long as far as planetary lives go. WASP-12b is so close to its star that it takes just over 1 Earth day to complete its orbit. Its own star is actually eating the planet's atmosphere, making it stretch into the shape of this egg. 10 million years from now, WASP-12b will be gone.
And some exoplanets are unimaginably huge. The biggest one of them is almost 7 times larger than Jupiter.
HD 100546b isn't just 7 times larger than Jupiter, it's also 750 times more massive. HD orbits its star 10 times further away than Jupiter orbits the Sun. That's pretty far, and it makes scientists wonder how this gigantic exoplanet formed so far away from its star.
There's no doubt that some exoplanets out there look promising for finding life. We've found quite a lot of them orbiting in the habitable zone of their stars. In fact, some of these worlds might even be better for life than Earth. But that's a story for another What If.
Scientists might have discovered life outside the solar system. Welcome to planet K2-18b. This exoplanet is 120